Thanks a lot. Don't believe all what he said. But so I'm here. I'm delighted to be here in this very special place to share with you some of the work we are doing both at MIT at the Sensible City Lab. It's a research group. We are at MIT, just on the other side of the river, around 30 people, and then 10 people in Singapore, and then also in our design office that's called Carlo Ratti in Italy, but now with also an office here. Now, and I wanted to start with this picture because something quite interesting happened in Formula One over the past 10, 15 years. 10, 15 years ago, if you wanted to win a Formula One race, you need a good car and a good driver, good physical things. Now, today, if you want to win a race, you also need something like this. A system that's made of thousands and thousands of sensors onto the car, collecting information in real time, sending it to those computers, where it's analyzed, it's processed, and decisions are made in real time. In other terms, as engineers, we call this a real-time control system, which is, a very simple thing based on two components, a sensing component and an actuating component, collecting information and responding to that information. And sensing and actuating is actually what every dynamic system does, what every living system does. When we see each other, when we meet each other, we sense each other, we collect information from each other, we shake hands and so on, and then we respond to that. Now, the amazing thing we believe is that today our cities are starting to behave like that Formula One racing car. Our cities have been covered with many, many different types of digital layers. Think about networks, just a cell phone network. Wasn't with us just 30 years ago, and now it's ubiquitous. Think about all the sensors we have. Think about all of this digital information that we have layered over space. And as a result, we believe that the way we understand cities, the way we actually can capture information from physical space, and the way we can respond to that is changing. A little bit like in that Formula One car. Well, why do we focus on cities? I shouldn't mention this to you, but I usually just put 4 numbers to say how much cities are important. 2, 50, 75, 80. Cities are 2% of the world's crust, but they're 50% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities more efficient or to change our cities, that can be a big deal on the global scale. Now, you say all of this is fine, but where is all of this leading us? And here I wanted to share with you something from an exhibition, a recent exhibition at MoMA, the Museum of Modern Art in New York. We were part of it, and the title of the exhibition was Talk to Me. The idea that today, because of this technology, our cities, our buildings, our objects are starting to talk back to us. The interaction we have with our space is starting to change. And if you want, it's almost as if every atom out there, or the physical world, were becoming both a sensor and an actuator. And it's nothing else than the old dream of Michelangelo and many, many others. When Michelangelo sculpted the Mose, so the story goes, he took a hammer, he threw the hammer at the Mose, there's still a little chip underneath, and he shouted, "Perché non parli? Why don't you speak?" And today, because of this technology, things, our cities, our buildings, our objects are starting to speak back to us. Now, I'll show you some examples of the work we are doing in this space, and I put together a few projects divided into sensing and actuating. Now, regarding sensing, this is a recent project we did here at MIT, where we started from a very simple question. If you take that computer that's there on the table, you know everything about it. You see it printed here. Every chip on that computer, you know where it was produced, how it moved on the planet, how it became that computer. Well, however, when you stop using that computer a few years from now, and you throw away it, then you know very little about it. Sometimes this is how it ends up, where it shouldn't end up from Europe. A lot of e-waste, electronic waste, goes to Africa. From the United States, a lot of it goes to Asia. And so our idea was, well, what if we could develop a little tag, a little chip? We put the chip onto trash, and then we can see what happens to trash when we throw it away. This was the first deployment we had in Seattle. We invited 500 volunteers. We had 3,000 tags. We started tagging every possible piece of waste, you know, from a can to electronic waste to normal things. And after adding the tags to all of that, then we started following it. So what you see here is 3,000 tags from Seattle. You see the day of deployment. After a few days, you see the main landfills next to Seattle. But then a big surprise. Actually, we're working with Waste Management, one of the largest waste management companies on the planet. And we were all surprised about how far things traveled. Everybody knows a little bit of that chain, but it hadn't been traced in its entirety. And you see, especially after 1 month or 2 months, still moving, especially e-waste, special waste. Still moving after 2 months. We thought that was right music. So what did we learn from this? Well, the first thing you can do if you're an engineer, you can take all this information, analyze it, and try to design a better system. If you looked at the traces, you saw some traces were absolutely moving in a chaotic way, going east and west. So there's a lot of energy we could actually save if we optimize a system like the way we remove and dispose our objects. Now, the other thing that was very important for us was how people responded to this information. Now, at the end of the project, actually somebody came to us and said, I used to drink water in plastic bottles every day and put the bottles out of my door and think they would disappear. But actually now, after the project, I know that's not the case. They don't disappear, they go a few miles from home and stay there forever. So I just changed my behavior, stopped drinking water in plastic bottles. So the idea that all this information we can collect today from our environment can actually help us to make better decisions and perhaps promote behavioral change. Now, there's a third thing that we discovered that was unexpected, and that happened more recently. That happened just a few months ago when a burglar came to our lab at MIT, here just the other side, and then stole a lot of stuff, including some of the tags that tell you where they go. And here is what happened. All right. Well, this was an example of sensing.
It was incredibly
today we can
stressful.
sense many things, collect information about many things.
Nevertheless, I think
This is a project we're doing with Audi, Volkswagen, about collecting information about people, drivers, and frustration on the road.
And Jesus. God. Okay.
Stop the car.
So we were just sideswiped. And right now my stress level should be through the roof. We've got the information, we'll have to process the data and see where it's really at.
So this about how today we can collect a lot of information from our daily lives, from our objects. Another beautiful source of information is actually information we all upload online. It's what, sometimes we call it crowd sensing. How we can use all this information to understand what goes on in our cities, in our building, in our space. In this project, for instance, our lab was one of the first ones to look at pictures. The pictures we all take, over the past, the amount of pictures we take has been increasing exponentially over the past few years. And then how could we use these pictures in order to better understand what happens in our cities? If you take these pictures, in this case on Flickr, publicly accessible, that everybody uploads and they're accessible to everybody, then you can learn interesting things. So what you see here, for instance, is Tuscany. You see to the left, and you see where people take pictures in Tuscany. And then you can zoom in and see where people take pictures in Florence. And then you can zoom in and actually look in the center of Florence, the most photographed places, the places where tourists go and take pictures. Now, if you do something slightly more sophisticated, you can go and look at the timestamp for every picture and see if that at the time it was taken, and then you can create traces. You see where people took pictures, and over time, you can create a trace like this. So what you see here is actually Italians and Americans as they move in Tuscany. And I got a questions for you. So where are Americans? To the left or to the right? Who thinks to the left? Raise your hands. Americans to the left? You need to make a decision, left or right. So Americans to the left, okay. Americans to the right. Okay, so, well, more or less 50-50, but, well, Americans are to the left here. And, you think, if you come from the United States, you go to Italy, maybe you go once in a lifetime or once every 10 years, and you will go to the main cities. So you go to Genoa, Pisa, Florence, the main touristy places. But if you're Italian, you've been there many times, and you go to try to discover those little villages in the middle of Tuscany. And look at how different it is. Some places, actually like the island of Elba, it's a beautiful little island, but it's not really known in the international tourist circles, but it's actually where a lot of Italians go. So, from this you can look at other things. In this case, that's something our students who are very interested at MIT was looking in real time at the best place to go clubbing in Barcelona, using the pictures. So you can look at all these pictures as they come out and get this kind of real-time map of the city. Believe it or not, they even managed to get a paper accepted on the geography of Britons and parties in Barcelona. They turn out to be very similar. And you can do other things, like you can look at the color of pictures, and then you almost monitor drought over the year. So drought is a big issue in Spain. The country gets very dry, and you get a lot of fires during the summer. And the way you do it today, you monitor it today, is using monitoring stations. But in this case, it's using all these pictures taken by people, looking at how the color changes over the year, and using it as a way to monitor drought over the country. Well, those are just some examples. I want to finish with, in terms of sensing, with the project we're doing in Singapore, where we're actually putting together many, many different data sources. Imagine combining all of this and getting almost like a real-time city, where you know all what is happening around yourself. Information about people. This is information from networks in Singapore. Information about energy consumption. In Singapore, it's related to temperature increase. When it gets very hot, then you turn on the air conditioning, so then the two things are correlated. How the city behaves during special events. What you see here is the Formula One racing in the city, so how all the population moves to the circuit at the time. Even simple things like, where it's raining and where the taxis are. There's actually the two things. When it rains, it's very difficult to find a taxi. And just if you share this information, you can do something, give something useful to taxi drivers and citizens. How the city expands and shrinks during the day because of traffic. And all the global flows, how they intersect with the local flows. So the mix between this real-time information inside the city and outside the city, connecting containers and flights, connecting Singapore to the planet and vice versa. So that was a quick summary of some of the projects in the space of sensing. How today we can understand our cities, our buildings, our environment in a different way, thanks to all this information that we didn't have just a few years ago. And just to give you a sense of the amount of information, think that if you take all the data produced by humanity from the beginning till 2003, well, that same amount of data we produced between yesterday and today is produced every day or a couple of days. So that gives you a sense of how much data we have and how we can use it to better understand our space. Now, however, we saw at the beginning, the point is, like in the Formula One racing, the point is not just to collect information, is actually to do actuation. Not just sensing, but responding to this information. And how is this going to happen at the level of the city? Well, the first thing is actually how we can take this and use it for promoting behavioral change, a bit as we started seeing in Trash Truck. In this project, for instance, we are working with the French railway company, and what you see here is the size of Paris based on travel time. How long it takes you to go to different parts of Paris. I'm sorry it's not very visible on the screen, but if you go by bicycle, by metro, or by car. However, if tomorrow you had another metric, say emissions of CO2, then this is how it would look. So very different, the opposite, by bicycle, by metro, and by car. So in this case, for instance, what we started doing is, is there any way we can quantify CO2 emissions that, all the CO2 that we all emit every day? CO2 that is emitted by transportation is 1/3 of the total, more or less. And how could we quantify it just with no user input? If you want, today there's many sites where you can go at the end of the day and you can say, today I've done that many miles by foot, by car, by plane, by horse, and whatever, and then you get the total CO2 emitted. But how can we do it without any user input? And so what we are doing here is using those sensors that we now all have on our bodies. Over the past few years, we kind of become like walking sensors. I think in this room, we have a few hundred cameras on our bodies. We got a few hundred accelerometers in all of the smartphones you have. And then, if you look at that, then it's interesting. Look at how your cell phone sees you when you're moving. This is your cell phone looking at you when you are on a bus, walking, biking, or on the metro. And that's actually the accelerometer that looks at the frequencies of your movement. So when you look at this, you actually get a way to detect the mode of transportation, and then you can get automatically the amount of CO2 being emitted, if you want the calories burned, where you have been, and with this information given as an app, then you can promote perhaps behavioral change. That's not public yet, but that's what we're working towards. So that's one example. Another example here is some work we started initially in the UK, here we built the largest ever social network, looking at the connections between all the people in the country, looking at a large amount of anonymized telecommunication data. And then we ask ourselves, how can we use it in order to better understand the shape of constituencies and the shape of regions in the UK? And this is a quick video. So every call builds a connection between two places. And then if we aggregate this for the whole country, we get something you could call the human network. How we're all connected with each other. And then we say, what if we could use that in order to redraw the map of the country? And then you got some interesting mathematical developments to do in order to achieve this. But what you find is quite interesting, that you get a new type of geography. Sorry, it's not too visible on the screen, but where some boundaries, some regions look like the traditional regions, some are different, and it's almost like a geography that's based not on the past, not on politics, not on history. It's really based on how we all behave and communicate with each other. And I'll show you now, actually, this was in the New York Times. We did with them a map with data from AT&T of the United States. What you see here is actually interesting, that the boundaries often are the same. And the boundaries of states are the same because usually they also have a river or mountains. The reasons why actually that separation means less connections between the states. But when you look at it, you actually see some states merging. Some parts, look at the top of Florida, to the west that actually gets connected to Louisiana. Some say splitting or merging, and that really is a geography that's based on how we all communicate and behave with each other. Well, just to jump from this, which is, in terms of actuation, is about behavioral change, about analyzing this data that can allow different type of planning, like we started doing, like we've been exploring in the UK. But then, a traditional way to do actuation is really through architecture. Architecture, the beautiful way that we can actually get information and respond to that and change our environment, design, change our cities, design something new. And here I wanted to share with you some examples. In this project, this was at the World Expo in Zaragoza in 2008. The theme of the expo was water, and the mayor of the city came to us with a very precise question. Water has been a beautiful ingredient of architecture and planning for thousands of years, especially in Spain, in Southern Europe. How could we use it today in a different way? And again, I'm sorry that it looks like the screen is a bit too wide, but imagine, the idea we came up with was, imagine you have a pipe, like you see there on the top, and on this pipe you've got many valves opening and closing and controlling drops of water. Then you can have a water wall that's almost like a living material. It's a water wall where you can write, you can show images, text, pattern. It also is, you see here, the person is approaching the water wall, and the water wall opens up to let you through and jump through. So we got the commission by the mayor to design the building at the entrance of the expo. We call the building Digital Water Pavilion. You see the whole building is made of water. No doors or windows, but when you approach it, it opens up to let you in. When you're inside, actually, all the walls expand and shrink based on how many people you have. So it becomes like a fluid, dynamic space. The roof is also covered with a thin layer of water. And, well, if you got too much wind, you can actually lower the roof to minimize splashing. Or at the end of the day, you can actually close the building and the whole architecture disappears. Hopefully without anybody underneath. We got sensors for that as well. That was the video. Here you can see actually the building before the opening. The face of the guy was very puzzled. If you look at his face, looking at what was happening with the water. Here you can look actually at the physical pixels, the pixels made of water with projections on them, and how the two things combine. Here it was myself trying not to get wet. And I should tell you now, actually, what happened one night when all of the sensors that detect people when they approach stopped working. The building is made of thousands of valves and sensors and so on, all connected to a computer. The computer crashed, and things stopped working. Well, actually, that night, we were terrified because the building would do its own crazy things and cuts and holes in the water and text, but without responding to people anymore. But that night was one of the most fun nights ever. The night we had thousands of kids from all of Zaragoza come to the building to play a different game. Not anymore a building that would open up to let you in, but a building that would do like this. And for us, it was important because as architects, as engineers, we always think that we know how people will use the stuff we design. But then reality, and especially human reality, is always a surprise. Now, at this point, I wanted to finish and starting to wrap up by showing you one project in more detail. Because what we've learned over the past 7-8 years at MIT and in the office is that actually the way design is happening is starting to change. And we knew how to make cities in the past. Cities were made of bricks and stone and concrete and glass, and we knew how to make them and how to design them and plan them. But how to marry concrete and silicon as cities will be tomorrow is something we still need to learn how to do, and something where we need actually many more people from different disciplines coming together and trying to make it happen. And this is why I want to share with you one project in more detail to show you how actually most of the projects in the lab develop and evolve in the lab or in the office. And in this case, it's a project we did for the city of Copenhagen. the mayor of Copenhagen came to us again with a very precise question about how digital technologies can help us in mobility and traffic, addressing some of the issues in mobility and traffic. And the interesting thing, we took a number of students from MIT and went to Copenhagen. The interesting thing is if you go to Copenhagen and if you think traffic in Copenhagen, that's what it looks like. Copenhagen is a city where 30 to 50% of all trips every day actually happen by bicycle. So we started working on bicycles and we came up with the following idea.
Welcome to the Copenhagen Wheel, the wheel that turns your ordinary bike into a smart electric hybrid. Quickly and easily, with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it for when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience of the city. It connects you with things a cyclist wants to know: upcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data, or share it with your friends and other cyclists through social networks like Facebook. As you ride, you also collect green miles. It's similar to a frequent flyer program, but good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your life and turn on the city. The Copenhagen Wheel.
And so what I wanted to do here was to share with you some of how the project then developed and how this was the video at the beginning. The project actually just got venture capital funding recently and is now a startup, so you'll be able to see the wheel soon in production. But we started with, again, usually at the beginning with a brainstorming and with a class with a number of students at MIT. What you see here are some of the initial ideas, including a kind of funny wheel that you see there on the right. The beginning was, yes, a wheel that could collect your energy, but there was nothing technical about it. Just a concept, not just a placeholder in a certain sense. But like most of the times when you got an idea and you don't know if it works or not, well, let's try it out. So what you see here is at the end of the workshop, we said, well, let's try to build a prototype. This was the first one we did at MIT together with another group. And then, the batteries, the motor, combining them together. And this was the first wheel. Tried it, it was working, and presented it with the mayor in Copenhagen. She liked it, so we said, okay, then let's go back to the drawing board. The drawing board started with defining better what we wanted to do, what were the objectives of this smart wheel. And then, again, redesigning it, putting everything together, choosing the motor, all the different pieces, assembling everything together. And then also, how do we connect the hub with the rim, with the outside? And this was the initial concept. Looked pretty bad, no? Then we thought about this. It looked much better, but actually didn't work. And if you think about it, this doesn't transmit the torque from the center, from the core, to the rim. And then we came up with this idea that was you have these spokes that connect, they go from the rim, connect to the hub, and just without being actually connected to the hub, just touch the hub, turn, and go back to the rim. So in tension, they're U-shaped spokes connecting the two. And here some people thought it would work, some people thought it wouldn't work, so again, let's try it out. Here's the first model. Another one, today is very quick to do models like this with 3D printers, so you just send it to a printer and you get a model like this. Adding the spokes. He was very skeptical, as you can tell. And, but actually this was working. So this is what became the way of spoke in the wheel. That was quite cool in the end. And then there was to control it through the phone. So here is where we had human-computer interaction designers, where we had programmers working on this in order to make sure that the phone could control everything. So you wouldn't need to buy anything, just program your phone and do everything from it. And we want to have sensors. Now, believe it or not, this is what happens today. Some people are sensing through bicycles like this, But we want to do something much more seamless, so we embedded in the bicycle these little sensors to measure CO exposure, NOx, basically air quality. And the interesting thing is that if you just take a few bicycles, as you see in this video, in a very little time, you cover a whole city. That's Copenhagen, just a few bicycles collecting information about air quality. And that is interesting because today the way we measure air quality is actually with a few fixed stations, but they're not very representative of what happens in the whole city. Actually, you might even end up in cases like what happened in Madrid a few years ago with the previous mayor, who kept on saying that actually air quality was getting better and better, till when people discovered he would just move in the measuring stations more and more inside the parks. So by doing this, actually with just a few bicycles, you can actually get very good information on air quality in the city. Well, you know, and then we had to build the prototypes to show to the mayor, and this was a summit where actually also President Obama, heads of states from many countries were in Copenhagen. So here you can see the different prototypes combining everything together, programming, the microprocessors, shipping everything, and then here is in Copenhagen. Here is the first video of the mayor of Copenhagen and mayor of Toronto trying it out.
I will follow. I said, run away, run away, run away. Oh, I felt it. Excellent. This bike is fantastic. It's incredible. It takes no effort. You see my bike? You start pedaling and the motor takes over. And then it will tell you the air quality, temperature. Incredible first. It's amazing to see an idea come to fruition like that.
All right, so and just to wrap up and to conclude, I wanted to you know, draw some conclusions from what we just saw about the development of a project. A project is this new field that some people call smart cities, where you combine actually electronics, architecture, design, planning, programming all together. And you know, the thing is something quite interesting, we believe. You know, this is how we used to think about knowledge till a few decades ago. The idea was that we could still fit everything into the right spot. That idea was still the idea of the Middle Ages, the idea of St. Thomas, who wrote the Summa and tried to put in the right spot everything, in the right pigeonhole, everything from the whole global knowledge. Now, we know that that's not the case anymore. We know that actually the map of knowledge, if we had to draw it, it might look more like something like this. It's a beautiful map that was on the cover of Science magazine, where actually they took 800,000 papers and looked at the links between these papers. And what you see is, you see links between brain research and mathematics and computer science. You see where everything is connected to everything else, a bit more like on the internet. And we believe that the same is happening now in architecture and planning. Sorry, this slide. The same is also happening in this article that was on Nature, where they actually saw that top papers in the past were usually by one single author, while actually the top papers today are papers by many authors from many disciplines. We believe that something similar is happening now in architecture. If you look at this, this is one of the most important images of architecture of the past century, and that Corbusier, the French architect, proposing his plan for Paris. Now, his plan was quite simple. It was actually demolish the whole city, just leave Notre Dame and a couple of other things as memories of the past, and replace everything with his new towers and skyscrapers. And if you look at that picture is really the hand of the architect, the hand of Le Corbusier, almost the hand of God, proposing his design from the top down to the city and to the people. Well, and people even said, that you couldn't draw collaboratively. There's a saying in design from the past century that says, a camel is a horse designed by a committee. So actually, if you put a committee together, they will not come up with a beautiful horse, they will come up with a camel. Well, now we know that actually we can make beautiful camels. We can make horses. That's an editorial of an issue on open source architecture, how we can actually use the same open source approach that we've seen so successful in many other fields and bring it to design, bring it to the way we design cities and buildings and objects. Actually, that was an editorial. I was asked by Domus, is one of the main design magazines in Europe, and to do this editorial, I said, well, why don't you do the editorial itself in a collaborative way? So we actually started on Wikipedia. We had Paolo Antonelli from MoMA, Nicolas Negroponte, John Bracken, many Ansuri Kobris, many other people starting to write it. And actually many, many more starting to change it and modify it. And you know, when Domus asks you for an editorial, they usually want a picture of somebody to put there. And we say, so what type of picture are we going to, a portrait of somebody who wrote it? They say, what type of portrait are we going to put there? And we just always say, well, we put a portrait with all of us together, actually overlap one on the top of the other. And my wish, in a certain sense, today is actually that the architect of this century, the architect of the next decades, will be a bit less like Le Corbusier with his hand from the top down, actually proposing his design for our cities without actually involving people, but more like a picture like this, an architect that really combines a bit of all of us. Thank you.